Hello, everyone. Welcome to the second day of Grammarly Tech event. My name is Lёша Levzhinsky. I'm a technical lead of browser extension team at Grammarly. I'm used to work with editor. Also, I use an editor team together with today's speaker, with Sasha. And today I'm very pleased to moderate meetup featuring Sasha, actually. Okay, a few words about the Grammarly Tech Week. So Grammarly Tech Week is a series of events hosted by Grammarly Ukraine team. During this week, we will hold 5 online meetups dedicated to various products and engineering topics. So yesterday was a great talk about what it's to be being an engineering manager at Grammarly. Tomorrow, Vitaly Braslavsky will talk about F# and how to build a flexible deployment system. On Thursday, Denise and I we will talk about testing at Grammarly, especially testing of the front end. And on the final day, Denise Kulik, our product manager, will talk about hidden complexity of NLP and ML products. From product manager perspective. Next one. Grammarly events have always been free to attend, and we keep this tradition. However, this time, in light of Russia's aggression against Ukraine, we invite meetup participants, all of you, to make a voluntary donation to trusted organizations that supports Ukraine. You can find suggested organization by following this QR code. Or you could select any of your choice. Do remember, there is no small donation. Every sum matters, every contribution counts. Thank you. A few more organizational questions about this session. Today we will have a talk by Sasha Suhak. After the talk, we will have a Q&A session. So please use Q&A tool in Zoom to ask your questions. Or you could post them in chat. Sasha will answer, I hope, all of them. After the event and Q&A session, we will have a separate Zoom call. The link will be posted at the end after the Sasha's talk, and it would be a network. It will be a networking session. In this Zoom call, you will be able to turn on your mic, turn on your camera, and ask questions to Sasha, to me, to everyone who will be from Grammarly, and actually you could ask on almost everything. Okay. Seems like the organization part is over, and finally I'm thrilled to welcome Sasha, software engineer at Grammarly. Sasha will share own experience using declarative reactive Grammarly. So please welcome Sasha. Your turns.
Hello. So I will be talking about React and how we use it at Grammarly. So let's dive in. So first, some background. Lёša already told you about different clients that Grammarly has. And when I first joined Grammarly a few years ago, I started working on the Grammarly editor. You can find it at app.grammarly.com. It's this application. And it's quite a complex application, especially when it comes to state management, because a lot of things are happening simultaneously, like user types text, and some new suggestions appear and sent from the background services at Grammarly. User interacts with suggestions by clicking on cards. So all that happens simultaneously, and we need to somehow manage all those updates and present a coherent UI to the user without blocking any interaction with the text. So, as you would imagine, it's not that easy. Recently, we've released, open sourced the new library called Embrace, which we think makes this type of applications easier to build. But instead of like just showing you the library and explaining how it works, I would like to like spend a first half of the presentation on the history, because I like history a lot, and I really like reading about history and about history of software engineering and why different things work the way they work today. So in order to understand like why did we build Embrace and why does it work like it does, I wanted to show some background and tell you like how did we why did we do this? So maybe if you have similar challenges, similar problems that we do have at Grammarly, maybe you get some ideas, or even could use this new library too. So let's dive into history. So the first version of the Grammarly editor, internally, I think it was version 2.5, but we like to think about it as a first version, looked like this. And it was implemented in mostly Vue.js, but also had some pieces of jQuery code. And it used our own implementation of the text editor, which did not support rich text, among other things. By 2015, this application was in cold support. So we did not add new features to this application, but by that time, the product team at Grammarly started thinking about new types of suggestions, which did not involve like simple text checks, but provided a more rich UX to the users. And the problem with the existing editor application was that its architecture did not support many of those features that we required to build this new Grammarly suggestions. So it had to be rewritten basically from scratch, and the team at Grammarly started looking at a new technical stack that we wanted to use for building this new this new version of the Grammarly editor. And this is one of the historical documents that I was able to find. It was done, I think, by Sergey Yavny, who is still working at Grammarly today. It compared different stacks that could be different technologies, frameworks that could be used to build UI on the web. So the team did comparison, did investigation, prototyping, and by 2016, we've decided that we will be using TypeScript and React to build this new version of the editor. And we liked FRP, functional reactive programming, a lot. A team looked at different existing libraries at that time, like Column.js, Bacon.js, and eventually decided to build our own version, which is called Focal, using RxJS. So Focal was important at that time, and it's still used at Grammarly today, and it's available on GitHub. You can check it out. It's a very nice small library for state management of React applications. So Grammarly editor version 2 was built, and it looked mostly like you see it today. What's interesting about this period is that when the team decided to build this new version of the editor, we quickly realized that it would be very hard for the team to both adopt a new technology, new architecture, and at the same time start adding new features. So the decision was to basically freeze any new features in the editor and spend this time, which is like almost half a year, to completely rewrite the old application with the new architecture. So no new features were added for almost half a year, and the team spent the time learning the new architecture and new technology. So it started with heavy use of object-oriented programming, focal, two-way data binding, but quickly a team realized that two-way data building doesn't work very well for us, and we started shifting more towards functional programming and using MVVM and MVI patterns to build this application. And for the text editor, we used Quill.js, and this is another historical document which Losha did. Losha, hello. At that time, comparing different kinds of text editors that were available at that time. So we used Quill for editor at Grammarly. So what's wrong with two-way data binding? It's nothing wrong, actually. Focal enables it, and it has some nice features that can be used to do two-way data binding. So this is a simple example. Focal provides atoms as a like basic containers for state. So atom is an observable implementation. It implements observable interface and can be used to store some piece of data, like text, for example, here, and it has some primitives and bindings to React that can be used to connect this state to UI. So, for example, here we use a focal version of input that binds its value to the value of the text property in the state that sits in the atom. So every time an atom emits a new value, an input will be updated, and every time a user types a new value in an input, a value in the atom will be updated too. So it works both ways. And atom is observable, so you can observe text changes in any other piece of the application, and you can write to the atom in some other place in the application. But we quickly realized that using this approach results in some cons or disadvantages. First, it's hard to reuse such components because it basically couples the view logic to model logic. So every time you want to use such component, you need to provide it with an atom that connects a view to the state. And it's hard to do action generic logic because there is no action as a first-class concept in this model. It's hard to do like logging, filtering, or some other things that abstract over the user action. And over time, when teams started using this approach, the logic of updates of the state become more complex over time. And team had to write some complex code to implement those features. So we quickly realized that it's better when we have separate actions as a concept in the architecture. And everyone who used Redux or other similar library knows this, that when you have an action as a value, you can do many useful things with it. So this is what we also did. So for example, imagine you have some state that contains text, and you have action that, for example, updates the state. So the same component can be now implemented in another approach where we separate the state and the way it is updated. So now state becomes read-only, and we can only use it to render the latest state using focal in its binding to React. And every time we want to update the state or do something, we then emit an action by writing to a corresponding observer. And now we need to have some place where we connect those two things together. So usually what we do, we create some state manager or a model, or we call it different names, but it's basically some place in the application that connects actions to state. So the trivial implementation would listen for all the actions, subscribe to them, and every time a new action is emitted, will modify the state that is stored in the atom. And so, which will result in emitting a new state value, which would result in re-rendering of the UI. So when we connect those things together, we create this state manager or model or whatever, and we pass the state and actions down to the component. So it's very similar to the model view intent pattern, and it's the way the Grammarly editor, most of the Grammarly editor features code is built today at Grammarly. So we store all the state of different pieces of the application in focal atoms. Different components subscribe to those states. They emit actions through Eric's observers, and then we compose or connect those things together in state managers or view models or effects. So we call it different names, but it's basically a place where those two things are connected. And we use RxJS for manipulating those streams of state updates and actions. And FPTS is our library of choice for doing functional programming with TypeScript. So it all worked nicely for us, but it also had a few inconveniences. So first is nesting. It's a thing that we all often do when using React. We compose components together. So imagine you have two components, like component 1, component 2, and each of those components has some state that it requires in order to render something. So component 1 has a state as a read-only atom of one type, component 2 has a state of read-only atom of another type, and then we want to define a component 3 that would compose or use first two components together. So what do? Well, we could create a bigger atom that composes those two states together, and then Focal conveniently has lenses or functions that could be used to narrow down the types of the bigger atom to a smaller one. So in a type-safe manner, we could select a piece of this atom to get a smaller one. So it all works nicely, but as the composition and nesting of the components becomes bigger, and the amount of code like this that you have to write to connect things together becomes bigger and more complex and harder to maintain. And same thing with actions. Like if we have two different components, each of those components emits some actions. How do we connect them or compose them together? We need to provide an observer now of that connects those two things together and can observe actions of both types. And then what do you do? Like, how do you pass this observer down to a smaller component? You either typecast to narrow the types, or you filter things, or you do some other wiring code that connects things together. So what we usually do is we like have a bigger observer that observes all the types of actions, and we typecast when we pass it down to a smaller React component. Again, this code becomes more complex and harder to maintain as a nesting becomes bigger. And another problem is that, or not a problem, but maybe it's a feature, but still it's not very convenient. When we have this nice model, we have this clean separation. State is a read-only observable, and actions is a observer, and if you want to change something, you emit an action. Anyway, it is possible to do some side effect here or there. So nothing prevents me from like writing an effect or creating an effect like this somewhere down in the components tree, and it results in unexpected behaviors, usually in bugs that are very hard to fix. So so over time, when we used this model, we thought about, okay, what would be the ideal solution to those inconveniences? Like maybe there could be a way to have actions as first class members of this model, so that it will be explicitly defined in some way that a component emits a specific action, and that there is no other way to change something other than emit an action. And maybe if we do this explicitly somehow, then it's possible to do some better kind of composition of states and actions when we compose components together, maybe in some even automatic way. So we thought about it over time, but there are also other challenges, like maintainability, for example. So Grammarly has many teams and many front-end teams, and some of them use TypeScript and React too. And we want to share some components, like when some team builds a component that can render a suggestion, for example, another team could use it in some other context. So overall, the amount of code grows, and the amount of number of different contexts in which this code is used also grows. So how to maintain this? Well, one of the problems, for example, that we had was where to define interfaces. So we want to have it's easier to maintain components, so we create interfaces for their properties. We say that, okay, counter is a React component that has these props. It has actions and state. Actions has this type, state has this type. Where do we put this interface? If we put it next to the component that seems logical, then we have a problem that how to say it, the way TypeScript resolves types, it's not required for the developer to explicitly use this interface name somewhere in some other module, right? So developer could just write some function that returns this, and it's hard to then connect pieces together, like how to find the code that actually provides this thing here. It's not that easy to do, especially when this code can be in another repository. So some other team may use this counter component, and they would use another type of model or a state manager, and it will be hard to understand where things are connecting together. Another option would be to define interfaces on the state management side of things. So what if we put these interfaces somewhere in our implementation of the state management for this component? Well, now this component is coupled to this thing, so it becomes harder to use this component in some other place, in some other repository by some other team at Grammarly. So also not ideal. So we wanted to have a one place where we could define state and action interfaces, and we wanted to dependencies be from the state management to the UI, not the other way around, so that UI could be reused across different teams at Grammarly without having to without coupling to the specific implementation of the state management. Another challenge is experiments. So we do a lot of experiments at Grammarly. An example usually it's some suggestion that has different variants. So this specific feature, for example, is a feature in the editor that can be used to accept many suggestions by a single click of a button. And we could have an experiment that renders or uses one of the two versions of this feature depending on the group that user belongs to. So how do we implement it in code? Well, usually it's as simple as writing if-else statements, right? So usually we have some feature flags on the user that says that some fancy component is enabled for the user, maybe. So if it is enabled, we render one version of the component. If it's not enabled, then we use some default implementation of the component. And it's very easy to write code like this. But the problem is that it scales not very well. So think like, what if we have more than 100 experiments and more than 100 if-else statements like placed all over the big code base with dependencies between them? It's easy to add those code like this, but it's hard to remove and hard to maintain over time. And usually it also involves many teams to coordinate this work. So it's over time it becomes a challenge. So since we use functional programming a lot and we like to write pure functions, at some point we thought, okay, but what if UI was like a data structure? What if it was like truly declarative? And we could write a function from one version of the UI to another version of the UI as a function from one data structure to another data structure. And it would be a type-safe way to write experiments, basically. Experiments as functions from UI. So it was an idea that we had. So all those hints that we had over time resulted in us building Embrace. So why is it called Embrace? Embrace, like we thought about, like what if we hug tightly the UI and squeeze all the side effects from it and make it like truly declarative in a way. So this is why we called it Embrace. It's a library for defining UI as a compositions of smaller UI components, and it focuses on doing this in a type-safe and immutable and declarative way. Underneath, it still uses React and its virtual DOM implementation, and it also still uses JS and Foco. So it uses all those things that we used to work with at Grammarly, but in some new way. So how does that work? The simplest building block in Embrace is UI part. So yeah, I think I saw some raised hands. So please, like, if you have a question, put it in the Q&A section in Zoom so you don't forget about it. But I will continue because otherwise it will be hard for me to maintain focus. So yeah, UI part. It's basically explicitly states what we already did before. Like we tried to define React components as things that accept observables of state and emit emit actions. So with the UI part, we tell it explicitly. We say, okay, it's a part of a UI that can accept observable of state, and it will, as a result, as a side effect of rendering some UI to the user, it will provide observable of actions. So in TypeScript, it looks like this. We have an interface that's called mount props. Let's not look at children. It's some specific way of extending this UI parts with it's basically an extensibility point. But other than that, it has state, which is observable of some generic type. And it has a notify function that can be used to emit a new action. So a UI part is a function that accepts this type of props, and it will return a React element. So sounds simple, I hope. And the mirrored version of this interface we called Flow. So flow is the other way around. It's a function that accepts observable of actions and returns an observable of state. So like new actions flow and result in new state versions. Again, simple TypeScript interface, a function that accepts actions as observable of generic type action and will return an observable generic type state. So what Embrace does is that if you give it a UI part like this and you provide it with a flow that matches the types, so types of action and state matches the flow types, so Embrace will mount it by connecting those two things together and returning and creating a React element that will be self-contained. So it will be updated, re-rendered as new actions are emitted inside of it, so to say. So the app model looks like this. To the right, we have what we call the UI tree. It's when we have smaller UI parts that we compose together, and a result is a one big UI tree that represents the entire UI of the application. And on the other side, we have app flow, which takes all those actions that could be emitted or created inside this application and provides as a result all the updates of the state of the entire application. So you see the data flows clockwise like this, and types always flow from the right to the left. And by that, I mean that every time we compose a smaller part to a larger one, we create a more complex type of the state and a more complex type of the actions. So let's look at the example, like how do you implement a counter using Embrace? Well, you need to do two things, a flow and a UI. So UI is a UI node. Node is a special type of part that doesn't have those slots that we didn't mention before, but it's basically a simplest UI part that you can create. So we define the UI part by saying a UI node by defining the type of its state, which is a number. So the state of the counter is a number, and then the state of the actions. So a counter as a UI part can emit two types of actions, plus or minus. So one of those actions can be emitted. And then we provide a function that accepts a state, which is observable of number, and a notify function that can notify plus or minus. And we use focal to render those things using focal being to React. So we create if that would update every time a state emits a new number value, and we have two buttons that they clicked will notify or emit a new action. So now we need to do the other way around. So we need to provide the flow that would accept those actions and emit a new types of state. So first we need to provide a UI. And now we need to do the flow. So how do we turn the observable of those actions to an observable of state? Well, the trivial implementation would be to scan or reduce all the actions and accumulate the numbers by adding one and subtracting one, right? And we also need always to provide an initial value so that the component can be rendered the first time, right? So initial value is 0. So now what we do is we connect those two things together. So using the special mount function, we can pass it the UI and the flow, and if the types match and TypeScript compiler is happy, we will get an application which is a React element as a result. And then you can do the normal React stuff, mounting it to the browser tab. So how some comparison to other frameworks or libraries, like comparing to pure React, we don't use hooks, so no side effects are allowed in our components. You are only allowed to emit actions and use observables of state to render updated version of the UI. So compared to the Redux, I think the main difference is that we don't need to do things manually, so we don't need to wire UI to state using some selectors or something. I will show you in a few slides how it works. So it all works automatically. And I think CycleJS is like most similar to our Embrace is was inspired by CycleJS, I guess, at some point. The difference is that we don't rely on selectors. We are more type safe and hopefully more declarative. So yeah, about I mentioned already the declarative word a lot and composing things together. So how does it work? So imagine we have two UI parts, one that and part B, and they have different types of state that result in the different types of actions, and we want to compose those things together and make a more complex, bigger thing. So Embrace magically, automatically does this for us. So it will produce, for example, a UI part that would have a more complex state that consists of those two different states and a more complex type of the actions as a result. And we have different types of kinds of compositions. So I showed you the node. It's simplest UI part that doesn't have any children, basically. But there are other kinds that we have in Embrace, and we're adding those types over time. So the grid, the node, list, union. I will not like spend a lot of time on explaining those things, but it's basically different kinds of ways you could compose parts together. So for example, if you want to render a list of parts, you would use list. If you want to render only part A or part B at the same time, you could use union for that. So an example would be like, what if we have some app component that provides some layout that consists of a header and a footer, and we wanted to put some parts at the place of the header and at the place of the footer. So maybe we have a footer that has a link that can be clicked, and when maybe we have in the header we have some title and a color that can be hovered or unhovered. I don't know. And the application can be scrolled, and it also has some default content maybe. So if we use UI node, which is one of the abstractions that Embrace provides, we could compose those things together, and Embrace would magically produce us a type of the application that we get as a result of it. So the type would be all those things that all those components they have, right? A link, a title, a color, content, and all those actions that can be emitted from the application. So the type of the flow that the developer would have to implement would be from this to this. And it's a little bit simplified, but like the basic is this. So yeah, and then I mentioned before experiments and wanting to write a function from one UI to another, and this is what we call patching. So Embrace also provides a function that can be used to change or patch one UI tree and turn it into another UI tree. Since the UI, until it is mounted, is simply a data structure, then we can like update it as a normal data structure by producing a new version of it. So again, continuing the example, like what if you have an app that has a header and a footer, but what if we want to have an experiment maybe, or some version of this UI that doesn't have any footer? We could accept this application as an input and then call a patch function on it, and in a type safe manner, zoom in basically on a piece inside of this application and call the footer like this. and then provide a function that changes it in a way. So here we just replace it with an empty node, but it could be some other function that changes footer from this node to some other UI part. And the result is a new version of the UI tree, which has a new type of state and a new type of actions based on the functions that we provide previously. So basically, all the final version of the UI can be expressed as a original unmodified UI passed to the number of functions that one by one modify declaratively or modify in some way this application UI, and the result of every such function would be passed as an input to the next function in a type-safe manner. So for example, if this experiment or a function changes the application by removing the footer, then the next function will not be able to reference this footer. It will not be there, so it will not be possible to make a mistake, or any breaking change would be immediately noticed as a compiler error. So let's look at some examples, like how do we use it at Grammarly already today. This is one of the examples, and it demonstrates usage of the same UI component in different applications. So we have the editor that I mentioned to the left, and also we have the same, well, not the same, but similar version of the editor in our browser extension. So this card here it's basically the same React component used here, but they look a little bit differently. For example, the shadows are different to the left, and it has some other pieces of UI around it. So what can we do with Embrace? With Embrace, we can say, we can use the patch function I mentioned to produce another version of the card list. So card list is this component that is a list of cards where every card corresponds to Grammarly suggestion. So how do we modify this card list to look like the one to the right? We can say, take this default implementation of the card list and then patch its item, every item of it in its content. So card list is a list, it has a content, which is a list of items, right? So we basically provide a path down to this item in a list, and then we write a function that changes this card in some way. And specifically, we wrap it into another component that provides some different versions of shadows or some other behavior. And then we do some other stuff that I will not spend time on explaining, but it's basically required to match the types of state and actions. So since we wrapped the original item into a new component, the types have changed. So we need to do some extra thing to still map those new types to the old ones so that we don't have to write a new version of the flow. But what I wanted to mention is that this is all type safe. So for example, one team could work on this component here in one repository, and then another team would have this code somewhere in their repository. And when this team produces a new result, a new version of the card list, maybe that has some other type of content, this code will not compile anymore. So it's easier that way to detect breaking changes. And another good thing is that this code can be placed in other repositories. So the original card list can have a default implementation, but another team could alter its behavior or representation without having to contribute a new code to the original repository. which makes maintaining things and coordinating things easier for us. Another example, so for example, we have an experiment that adds this feature that I mentioned before that can be used to accept a number of suggestions at once by clicking a button. And we could have two different versions of the applications depending like how lucky you are as a user. Maybe you're an experiment, maybe you are in the experiment that has this feature enabled. So again, we can patch the original card list by adding a new, so it has its content, right? A card list has content, and we can basically add a new piece of UI on top of it by wrapping it using some Embrace abstractions. So now the original card list is not changed, the code is not modified, but the new version of the card list will have a new feature rendered on top of its content. Okay, another example, it's a feature where, well, again, it's the same feature, a feature that can be used to accept multiple suggestions. It has different states, right? So it can be hidden. Maybe we don't have enough suggestions that can be accepted at once. Or it can be minimized, like user clicked on some other card, this one is minimized, but when user clicks on it, we want to render this representation of this feature. So we basically have three kinds of feature, how it is rendered on the UI. And we can use union from Embrace to do that. So we can use union and say, okay, we have three kinds of state or kinds of UI for this feature, and for every such kind, we provide a UI part that can be used to render it. And union will handle the switching between those kinds when corresponding action is emitted. Another example, deactivated suggestions is a feature that can be used to turn on or off different kinds of suggestions. And it's basically a list of those suggestions. Every suggestion has some button. Every type of a suggestion has a button to turn it on or off. So another example where we can create a UI part that can be used to represent a single item in a list, and then use list UI abstraction from Embrace to automatically create a new component that would represent a list of those things. So a developer doesn't have to write to create manually a component that would render a list of other things. So as I showed you, like Embrace is used already today at Grammarly editor. It is also used in pieces of Grammarly web browser extension. It continues to evolve. There are some challenges, specifically like with animations, like how do you represent animations declaratively? It's not that easy. So we're still thinking about those. Lists also not very easy to do, especially like in terms of composing states together and representing the state of a final list. So some changes could be expected around ergonomics, how the developer experience. So we're trying to optimize that over time. But already today, it gives us like this way of defining UI logic declaratively, and I think it makes reusing components easier and detecting breaking changes and maintaining those components over time easier for us, and coordinating different teams. So different teams could now work on their versions of same UI component without having to contribute changes to each other's repositories. Yeah, it works quite nicely. So yeah, this is all I wanted to show you. Of course, limited time, and if you're interested, please go to the repository, Grammarly, GitHub repository for Embrace at Grammarly. It has documentation and samples that you could play around with and read through if you're interested. And if you think that these kinds of problems are interesting to you, you can join us. We are hiring in Ukraine, in European Union, in US, in Canada. So if you're in one of those places and you want to work on this and other interesting things together with us, please join, and you can use this QR code as a link.